Okay, we're at problem number 10 from the Wastewater Collection Math book at SewerGeek.com. If a plant receives a flow of 150 MGD at 3 feet per second, what minimum pipe size would be needed? Oh, we're going to simplify the problem a little bit. Before we do that, we're going to take a look at the answers. They're in inches, but you're going to have to convert this to feet first because you need to convert MGD into cubic feet per second in order for the units to work. Let's go ahead and do that now first. And that formula for the MGD is cubic feet per second equals 1.55 times MGD. 1.55 times 150 is going to be about 230. We'll take a look. 1.55 times 150, 232. That's going to be 232 cubic feet per second. And I'll just cross that off and write 232 feet cubed per second. To simplify the problem a little bit. So now we're in the same units up here. And we could take a look at this. When they put these problems together, they're looking for mistakes that you're likely to make. And one mistake you're likely to make is to figure out this sewer diameter in feet and then forget to convert it to inches, and you're going to see the feet over here. So here's what we have: is we have 10 inches, 120 inches, 48, and 72. But if you've messed up and you got 10 feet, you'd pick 10, and 120 inches is also 10 feet. So you should look for things like this because they want you to grab that 10. And we'll see that the answer is going to be C before we do any math. You get used to looking for things like this, it'll really save you a lot of trouble. So let's go ahead and do the problem anyway. We're going to use the Q equals AB formula. Flow equals area times velocity. And one form of that would be cubic feet per second equals feet squared times feet per second. So I'm going to end up with 232 cubic feet per second equals feet squared, don't have it yet, times 3 feet per second. We go ahead and get this feet squared by itself. So if I divide both sides by 3 feet per second, that goes away. 3 feet per second. Divide that. 232 divided by 3. The units are going to be feet squared because the seconds drop out and you end up with feet cubed minus feet is going to be feet squared. I've got 232 in the calculator already, so I'm just going to divide it by 3. And that's going to give me 77.5 feet squared equals feet squared. That's the area in feet squared. So I have another formula because what I need is a diameter and I don't have it. So I'm going to have area in feet squared equals diameter squared times 0.785. So I'm going to go 77.5 feet squared equals diameter squared times 0.785. And I want to get this by itself, so divide both sides by 0.785. And that's going to give me diameter squared. So if I take 77.5 divided by 0.785, that's going to give me 98.73. 98.73 equals diameter squared. It's just, we basically just put the corners back on the circle. So I want to get this diameter by itself, so I'm going to square root both sides. So the square root of 98.73 feet squared is going to equal the diameter. So I'm just going to go 98.73. Oops. I have to hit the square root first on this button. 98.73. The square root of that is going to be 9.936. 9.936 feet equals diameter. Well, if you weren't paying attention, you would go 10. I got it. But you have to multiply times 12 to turn it into inches. 12 feet. Whoops. 12 inches per foot. So 9.936 times 12 is going to give you 119.23 inches. So that's going to be C. 120 inches is the minimum size.